Okay, just busy making coffee still, but that should be ready in a minute or two. See, everything's up and running. Let's go. Okay, so I made significant changes to this thing last time, and yet I'm thinking of more. But actually, so in the same time, oh shit, I need to open up Jira. I need to kind of rethink this project because I don't know. Yeah, I'm not sure what I want to do 100% yet. A Jira alternative, baited. How do I go to? Is that it? What? Just go into the Jira dashboard. Where's the dashboard? So this is a Jira landing page. So I just click get started. Ah, there we go. Guess I should have just clicked there. So yeah, I just want to check what I wrote on this thing because I'm thinking of either changing the project, still do what it does, but to do more. Some ugly stuff on my mat, or dirty stuff that I'm just wiping off. Wait, what's happening here? I don't want to go to conference. God damn it. How hard is it to just get into my Jira dashboard? Or is this where I need to be? Close. I don't want... What was that? Why is it so hard to get into Jira? I don't remember it being like this last time. This one. Because yeah, I do still want to do the Android pilot thing, but that's why I need to think about what I want to do with this, because it's not just an RC mixer. It's RC mixer and autopilot, but the autopilot, I see no need to integrate this with existing autopilots. Because this thing is intended to turn your phone into an autopilot. So it just needs to bridge the gap between a mobile device and a GPIO system, basically. There's so many other autopilot features like CAN, your CAN communication, your telemetry, your power redundancy. I think that could be long-term stuff, but for now, let's see, I'll put this all together in one project. I should not actually have. Wait, how do I rename this? Ah, clumsy fingers. Why are my fingers so clumsy tonight? I never had external integration, so it's fine. What is this category? Okay, so now I do still want an LCD interface. This doesn't form part of this project. I'm going to delete that. Really? And enter doesn't work. I have to click it. That's annoying. This is also technically, oops, not part of the project. God damn it. Well, this seems to have become a lot more complicated. It's actually technically done. But yeah, let me go grab my coffee quick. Okay. So let's see. I need the LCD interface. Technically, I'm done with that. I could say, or to an extent. So let's see what we did here. We have vehicle type, vehicle class. I'm wondering, what does this chip have in terms of communication? Let's see. I think I did see CAN. Let's check something quick. Wait, what did I want to check? I wanted to check all the interfaces. Maybe I shouldn't have gone support. Maybe just learn more. Let me scroll faster. City website. Don't do this. Wait, you're gonna make me scroll. Oh, there, specs. Mavlink serial interface. Is that for connecting it directly to the GCS or what? And it's got 4 of them. Wait, is that the number of interfaces? Yeah, it's the number of interfaces. So it has 4 Mavlink serial interfaces. Because that's something we're going to have to look at as well, is Mavlink, because that's a communication protocol used by autopilots and GCSs, from my understanding. But yeah, it's just pretty much CAN, I2C, and pulse width modulation. What does a GPS connection use? These people, hold on. Let's go. What's that? Flying robot? That one. Let me see what kind of connections these things use. Is that a pigtail? Do they all use pigtails or what? What interface does it use? Isn't there like a specifications button? Really? Take me to a freaking sales page. This is the same website I'm on now, but it doesn't show any information. I want to see what kind of connection it uses. So it uses CAN by the looks of it, but a specific type of CAN. So what, does it plug into one of these? What is this? Is this a whole? This is a whole nav system, not just a GPS module. Oh, yeah, you see. Wait, so this thing isn't just a GPS? What is this called? Oh. That explains it. I thought it's just a GPS. Oops. What? Didn't realize it just appends it. No, man. No way, that's just a GPS. Well, for that price, I would think it's more than GPS. But for that price, I think it's more than GPS. These are just GPS. But this is also 8 grand. I don't get, why does it have the autopilot and everything? Because people are connecting these things to the Cube Orange, from my understanding. But if the Cube Orange has autopilot, why do you need this thing then? This must just be a GPS. I don't get it. Wait. They call it a navigation module, not just a GPS. What does RTK stand for? Kinematic global navigation. So it is just a GPS. But then why does this website say it has all this shit? It's got the same family of chip as the autopilot itself. No wonder it's so expensive. Even as I'm using stuff. What the hell? Why do they use them in combination then, rather than just standalone? I don't get it. Because from my understanding, I don't need this thing. Then, does a... Wait, let's go check out the cube. Specs again. Ah, not support, my bad. Barometric sensor, is that what this is? Pressure sensor, so pretty much a baro sensor. Doesn't have any other type of sensor, so this doesn't have a built-in GPS. I thought this thing has a GPS in. So then, basically, this thing is just a glorified gyro with pretty advanced firmware, to put it that way. Oh, there. Oh, but that's just the number of supported. That sucks though. So you need to buy your GPS separate. I thought it was built into the same thing. You're telling me I'm going to have to fish out another $5,000 just for the GPS? Fuck me. Well, that's unsettling to know. I never realized that. Still no GPS though. No, the specs. Give me specs. There's no specs link. But yeah, I would assume it also has no GPS. Why wouldn't they integrate the GPS though? Or like at least give you a GPS with it. You just stick onto the freaking... Because now the GPS units are shipping with a whole bunch of features that the autopilot already has. Why? Now you're paying all that extra money for that. Let's see. Maybe I'm just looking at very fancy versions. GNSS module. centimeter level accuracy. So maybe it does use the IMSs in determining its current position, but IMUs, I mean. Oh yeah, sorry. Single in. I'm trying to see if there's any local sites that pop up. There's RS components. These are just the chips. That doesn't help me much. Those are probably proto boards. Still cheaper than a freaking CAN module, the whole module. But see, from my understanding, your GPS module is normally just a little freaking, just like a GPS antenna. There's no IMUs and shit like that. Why does it need all that? Autopilot has it all. $100. See, that's not even that expensive. And it's got USB-C. This looks pretty current. This is also more than just a GNSS. This is an autopilot. What's this? It's a really advanced GPS or GNSS. But I feel like it's a real big waste if your GNSS and your autopilot has so much of the same hardware. Like, can't they just communicate the parameters of each sensor to the other component so that it uses that in its calculations? I mean, to pay so much just because this thing has all a bunch of stuff you already have is kind of pointless. Without antenna. See, look at this thing. That's $1,000 already, and that's all you really need for GPS. Surely those aren't the only ones that work with it. Maybe this works with it. Let's see. See, it's UART though. Oh wait. Everything but CAN. Why doesn't it have CAN? This looks like an ESC though. Telemetry sensor. Ah. What is this thing? $1,100. I don't know how this works. So you're still then supposed to connect a telemetry radio? Or is no way that it's radio frequency or communication frequency? Over a radio signal, at least. Anyway, I'm getting sidetracked. So yeah, they don't have a lot of GPS modules, but now... Why is it not auto-completing? Auto-complete. Oh, DIY. It's because that's why I never... Every now and then I have this problem and I don't realize what I'm doing wrong. See what these guys have. Curious what communication they use. Let's look at this one, for example. Wait, so is this Wi-Fi already? No, but it's a hat, which means it has to plug in, right? What? This thing has GSM? Oh, I didn't see the GSM part. I didn't say what communication method it uses. Must be this. Which means it's using UART, which isn't what we want. We want CAN. So let's think for a second. Do we really need a GPS for the thing to fly? I mean, if you want long distance kind of stuff, great. No, even for short distances, because the magnet stuff is unreliable. You need GPS for, you don't need centimeter level accuracy. Your IMUs can take care of that. I'm sure you can go without a GPS. It's too risky. Could lose your plane that way. You need a GPS. God damn it. I don't know it's going to be that expensive just for GPS as well. Fuck, so I need to add that to the list as well. But let's see. Maybe you can fly it without GPS. Just for like tests. Cube Pilot. Without a GPS module attached, particularly for manually flight modes or specific indoor navigation setups. So yeah, you definitely don't want it to go out of line of sight. Also, how would it work if you want to take control? Because you got your GCS, but what if you want to rather fly it on a radio control instead of your GCS? That's the issue, is troubleshooting. Oh, we don't have a system like that from my understanding, because we won't have vision to begin with. So whatever they explain doesn't apply. But I'm just thinking like the consequences of flying without a GPS. If the thing starts to go off position, you need to be able to take control where your that's where your GCS comes in. So yeah, I wouldn't be running this thing without a GCS. And also a GCS is basically just a computer running mission planner. But then I still need a telemetry radio. I think these guys had it, if I remember correctly. It wasn't this one though. It's called the 3DR. 3DR, don't they have the 3DR? If I remember correctly. This is the one. Neotronics, they're the ones that had it. Yeah, it's not too expensive. But also, no, man. That other website had one, Flying Robot. They definitely had one, did they not? I'm pretty sure they had it, the 3DR. Maybe they just sold out. Because they had a newer one as well. I actually want the newer one. I don't want this one. This is an older one. But either way, yeah. So that needs to be factored in. As long as you have the telemetry radio, I think you're good with taking control of the drone if it loses positioning or something goes wrong. And eventually I'll probably have to get a fancy GPS in. But yeah, that's pretty much what I wanted to figure out, was like the direction of my project and RC stuff. Because with RC, you can pretty much, you get a device that merges all the signals from your receiver into a single communication port that you plug into your autopilot. Then it knows, then it can communicate with your receiver. It's just the autopilot system. I don't know how it knows when to switch. Let's Google it. Until I have the stuff, I wouldn't know, so I'll have to Google it. Sometimes you gotta be a bit more specific. Flip the mode switch to the position, but where? On your radio, on your Q control center? Where do you do it? What switch are you referring to? What fucking switch, you stupid AI? That's what I want to know. I guess we'll find out when we have the hardware one day. But yeah, let's give this some more thought. So, coffee's finished already, damn. Where was it this one? I mean, it was this, wasn't it? Wait, it was in the C2CPP here. This is where I did it. So this is pretty much all my channels, but what I want to do, so these are input channels and output channels, but I want the input and output system to support multiple communication systems like CAN as well. That's all I wanted to see here. Does it actually have CAN? Which I believe it does. But it does not. It doesn't count as analog, does it? No. I thought this had CAN. Or am I checking the wrong places? Nope. It's not under timers, is it? Or CAN wouldn't be timer driven. That's the thing. It's a communication protocol like serial. It wouldn't be timer driven. So no, I don't think this has CAN. I don't see the words CAN written anywhere, so no. Wait, it's not. Stupid search, because you're obviously slow. No, the word CAN isn't written anywhere, so it doesn't have CAN. I thought this thing had CAN buses. What about the 411 then? From my understanding, they're pretty much identical. I don't know if the 411 is going to have CAN. Nope. No CAN. Could have sworn these things had CAN buses. Something has a CAN bus that I play with. Is it Arduino? No. Pretty sure it's STM32s. Unless it's not a communication protocol that's built into hardware, maybe it's something you've got to do separate, like your own software level communication. Apparently it has CAN. It's equipped with a CAN bus controller. Okay, so I assume they just implement their own form of CAN communication. Because yeah, there's a breakdown of their byte, the communication bytes that get sent, but no, this, hold on, so you just go to GPIO and there's a CAN option, is that right? Wait, where is GPIO? There. I don't see any CAN stuff here. Any timers. This chip must have CAN while mine doesn't. Okay, what the fuck is this shit? Stupid ads. Pretty sure it doesn't have CAN, and the one that I was looking at had CAN. And judging by the existence of this question, I would assume it doesn't. And the one I was looking at was one that does. Fuck, man, I could have sworn these things had a CAN bus. No, man. Let's ask the AI. Let's see what the AI says. It does not have a CAN transceiver. No, man. Which toys of mine have CAN buses in? Is it maybe the ESP32? I can't remember which one I have. The C3 Mini or some shit. I've actually got two different ESP32s. I've got a Vroom as well. But again, that doesn't solve my problem. I want to stick to STM32. I realize now that's a mistake, but because even for advanced autopiloting capabilities, the STM32s I'm playing with is too slow. That's why I wanted an external autopilot, but without a CAN bus, I sure as hell I'm not going to build a system with a CAN extender, so that sucks. I didn't even realize that. What other communication does the autopilot have? What am I doing? I2C. That one I can do. What's a debug interface? It's a STM32, so it's probably the JTAG or SWD or some shit. But yeah, I think I2C is going to be our go-to one. There's no dedicated use for I2C, is there? It's only showing one I2C port, but here it says 2. Oh, but it could be 2 with 4 pins. Wait, where's that? I2C is there. It may very well have 4 pins. Data and clock for both interfaces. I don't know. No, but it's I2C2, so there's an I2C1 somewhere. It has to be. I don't see it. But either way, it has I2C. So speed is pretty low on I2C though. What was it, like 10 megabit? Did I do I2C? No, I did it when I did the screen. It's disabled right now. But if I were to enable it, 10 megabit. Wait, 10 is 100 kilohertz. Still pretty slow. 100 kilohertz is slow as hell. The other thing I don't know is the USB communication speed limitation. That's also 12 megabits. The speed, however, isn't the problem. It's more like the latency. If I get good latency, I have no issues. If I get bad latency, everything falls apart. But okay, so here's what I'm thinking. You take the mobile device connected to the STM32 using USB-C. That'll then communicate IMU information across to the STM32, which then relays it. What is this? Oh, Captain Denton. Yeah, so the STM32 can then relay that information to the actual autopilot. But again, no, the phone is the autopilot. It's just if I wanted other things to be able to communicate back to the autopilot, like the cell phone, the mobile device, then you need I2C. You can actually use any one of these communication protocols. It's just that the other autopilots don't use them natively. You still make it work with other sensors and devices. So, fine, let's do it that way. Where's that draw.io thing I had? I wonder if it'll remember my last drawing. But I did download them in case it doesn't. Ah, it remembered them. Okay, so I'll iterate on this. This is no longer the case. Get rid of that. Actually, oops, that can remain. Can just add to it. Do this. Ah. Why did the text go so small? Also, oops, can I make this arrow bidirectional? Oh, it's too late. There. No? How do you make the end one an arrow as well? Am I blind? I'm missing something. There must be a way to make this work like that. Oh, there. Uh-huh. Da-da-da-da. Wrong one, though. Well, we don't have other ones. So peripherals can be I2C, SPI, UART. We don't have CAN, so we're screwed with CAN. What else do we have? Could do input capture, but all that falls under timer stuff, so I don't care about that. What? Okay, so I got all the text selected. It doesn't increase when I change the value. That's silly. You have to make me click it. That's so rude. And then it doesn't even change. God damn it. There. Okay, so this still applies. It's still pulse width modulation, except it's no longer outputting to speed control. It could be a speed control or a servo. Should have just kept it there. So you're still going to have the mobile device, the STM32, any peripherals you want to add, and then the actual control surfaces of your vehicle. But the problem is, what about video feeds and shit? Could that be useful to send via the communication? But yeah, the STM32's bandwidth is a limitation, so you can't. No video feed here. It's too slow. You can always send it directly from the mobile device, use its camera, but then you're going to have to design your aircraft so you can fit a phone and use its camera. But yeah, this is pretty much what I want to stick to for now. And then you could always build an expansion board that could use one of these communication protocols and convert it into CAN bus or whatever. Wait, where's that website again? What does telemetry use? And an ADC. So an ADC exists on an STM32. But what is the telemetry communication? Because from my understanding, your telemetry is a video feed. It's usually from you output your video, your camera, into a device called an OSD, which then draws over that video feed and then finally sends it to your video transmitter. And the telemetry is fed into it. Okay, no, so the telemetry is separate. So that's the flight controller's communication. Data downlink from vehicle. So it's UART. I don't know what the on-circuit protocol is, not the freaking radio. Isn't there an easier way? Maybe I shouldn't say Ardu Pilot. Maybe I should say, what's this thing called? Pixhawk. I don't want to know the wireless. How do I specify? I want to know the circuit protocol. The protocol. Fucking AI. Actually, it's me just being lazy and then blaming the tools. It tells me everything. Luckily, it does keep context, so you can just do that. It should fix it. Fuck me, I said 4 components. But maybe it's still giving me the right answer. SPI, I2C, and UART. So it's everything I already know. The only problem I have is CAN. Wait, CAN is area. Wait, so this is packet based? It's not. Does it have packet refetching? I didn't know that. I don't know it stands for controlled area network. I thought it's just like serial, like UART. Huh. But yeah, okay, so it does use those communication methods. I guess it depends on model to model what you use. Here's my Twitch. Did I close? I took the wrong window. But okay, so it still uses all the same communication protocols and stuff that I'm used to, except for CAN. But because I would like to make telemetry available from the STM32 if I can. The stuff that the phone collects, that you can also output it to an OSD or mix it with a video feed or something like that. You see what they also did on the flight controllers is I think they the same way you connect your RC receiver, they combine all the channels into like one communication protocol. So I wonder if I could also, what do you call it, squeeze them in like that or minify the communication, something. What's the fastest of these? SPI. In theory, well, I guess it's the same if it's single device communication. Same as UART. Now let's see here. If we do want to add all that stuff. So right now it's built for timer channel. So you're going to have to build an input channel. So instead of having that class be timer specific, you're going to have to tell it to be able to use multiple types of inputs and outputs, which could either be your. But the thing is now, you have a single UART communication interface, but you have 4 control surfaces. So instead of having 4 input channels, you'd need 1 input channel, but map its values to multiple outputs. That's where some of the stuff I was thinking of last time came in. I actually drew a picture, very pretty picture. Where did I put that picture? Inside my pictures. No. Here, very pretty picture. But yeah, this is the idea. So you have multiple outputs, you have multiple inputs, and you can switch from input to output and vice versa. And then in between your inputs and outputs, you have mixing systems, also modular, also one-to-many and many-to-one relationships. So you can then have a single input, read multiple values distributed to the output, which could have multiple channels. So I'm thinking your mixer has to be told what type of input are you receiving. Are you receiving something where you're already reading multiple channels, or are you reading everything in one channel and then having a split up? Unless I think we should do it that way, because then we can do input systems that aren't just for control surfaces, that are also for other more advanced things. But then how do you identify its individual channels? I think this input-output system must only be used for control surfaces, for controlling the vehicle. Everything else, I should build something separately for. It's going to require quite a bit of thinking. Because you don't want it separately necessarily, because you do want to be able to take any type of random user built input system and make it compatible as a control mechanism for the vehicle. But yeah, we got to keep in mind on the STM32, we're very limited with inputs and output ports. I don't even know how many of these are actually usable for stuff. And some of them, when you occupy it, it disables other communication methods. Like some of the stuff here would now be disabled, the ones with the exclamation marks. But most of the comms are open. It's just UART2 that's, I've got one UART port, which is good enough, I guess. Shutdowns of SPI and I2C. So no, I don't think pins are that big of an issue. So how about this? We only cater for input systems that are intended to control the vehicle. Anything else, we don't cater for. No, but I want telemetry. What? If we built an input system specifically for telemetry, would we use it for anything other than stats? I don't think so. So instead of trying to build something dynamic, let's just like hard code build a freaking telemetry input. But it would have to work with either I2C, SPI, or UART. So it would have to be a multi-communication protocol telemetry system. Is that other drawing there? See, so the OSD, the device you put in your aircraft. No, wait, but that's only for overlaying on the VTX. Your telemetry. The mobile device would have to generate the telemetry, meaning it's going to be communicated via USB. How does the telemetry radios communicate? Well, I assume if it plugs directly into the telemetry port, it's also I2C or SPI or something based. Because that's the only thing you need to cater for, really, is a telemetry radio. The mobile device will do most of the other shit. So I'm gonna add a comment here. Sorry, output. Because actually it's both input output, because the input is going to be USB, but that's also going to be our autopilot. I think at the end of the day, 90% of the work is going to be happening on the mobile app. And then this thing's just going to control motor. So yeah, this thing doesn't need to become that complicated, this program. What we have here is already also probably about 90% of what we're going to need here. It's just a telemetry input, I think, output that we're still going to need. This here, I think it's unlikely that we ever move away from input capture and pulse width modulation for input output. Telemetry is one thing that'll use I2C, but everything else should be good as is. So then I need to actually start looking at building a mobile app, hooking up this thing's USB interface. I think I might have actually enabled it already. Let's see. No, I have not. Device only. And then what's the next part? Middleware, USB device, communication device. I'll just keep this vanilla for now. What's this? What did I change? Which file here is changed? This one? Okay. So now I've added the USB device. Now the only thing with that USB is, though, that I normally, guess maybe I haven't tried enough yet. It should be doable, but to move everything from here. Oh, but the reason I think this doesn't work was because my files are C++ and this is C. That's why it works here. Because I move the USB device code into my own library, but if it's C++ and doesn't work with C++, then I cannot. How did I do it last time? I created a send method here and I called it from C++. That's how I did it. And that worked. Even though I struggled my ass off to get it to work because there was some weird ass issue. I think let's do that. User code begin. What the fuck? Why does it do shit like this? What size can the USB send? Can't remember now, but there was a limit. I think it's the 1024 or 512. Where's that IOC? Sorry, middleware. That's it, 512 per byte, no 8. That's the buffer size. String, oh, that's string, yeah, it's the buffer size, 1024, so that is right. Is that main? So if it's 1024 int 8 underscore 16. That's wrong. What did I do? Then so that's the length, and then we're gonna go. I think it's hull underscore CDC. No man, or is it just CDC? Or something CDC, if I remember correctly. I might have examples somewhere. Come on. That. Oopsie. Is this a working or the broken one? I can't remember now. But I think this might be the working one. I had to change it to constant char like that for it to work. I think that was the solution. Can't remember. But we'll get there and struggle our ass off again until we get it to work. Still bold, so that's good. Why does it not like this? I have no idea. Implicit declaration. It's not a declaration. I don't get it. Anyway, okay, so there's our USB send. So we're going to have to call it from C++. By including the main.h file, which I don't like doing, but that's the only way I could get it to work if we want to send USB data. But in order to do this, there's also another thing I noticed with USB is if you don't immediately start, or you have to have like a listening thing to listen for connection, because otherwise it goes into like an error handler, if I remember correctly, and it wasn't this error handler, it was something else, I think. Why are my breakpoints disabled? But yeah, I want to see, I'm pretty sure it hits this error handler if you don't do anything with the USB for a while. If it doesn't, which other one would it hit? They all hit the normal error handler. Okay, so I think it would be that error handler. So doesn't show you what the error is though. But yeah, I think I should upload this code and run it for a bit to see what it does. Okay, so it's running now and debugging. So if it hits that error, it should hit our breakpoint, hopefully. But yeah, I'm pretty sure the USB times out. So we have to figure out how to do USB properly if that is the case. There's a USB in it. Right, it was this one. Let's close all others. Okay, so what I do is I set up my output channels, set up my input channels. Have I even tested this code? I think I have. Oh, wrong shortcut. Oops. There's an input capture callback on the input system. We haven't written code here yet. We still got to copy over code from one of the old projects. So I haven't done this part yet. Do we do output? Yeah, we did basic. So we start pulse width modulation and then write 0 to it. Also, I used an array here. Why did I do that? Yeah, this I still need to expand on heavily as well. This needs to work dynamically based on vehicle type. There's a shit ton of work left for this project. If you want to do it properly, which I do. So, kind of feel intimidated now. Noticing how far behind I still am. Like, this can't even do what my other project could yet. Even though it's fancier code. I'm thinking like early version. No. See, I want to cater for multiple vehicle types, even though I don't have others to test it with. But a lot of the code doesn't need to be tested to know if it's done correctly. Like, we know a car is only going to have throttle and steering. And then your autopilot switch to 3-channel. But yeah, I think I'm going to go make another cup of coffee, think about this a bit, and then maybe draw it out a bit to plan it. BRB. Okay, so I think I might as well build this while I'm at it. So we want to look at the vehicle type and determine the number of minimum input. Okay, but hold on. I actually thought about this the other day. For each vehicle type, we create an object, a class or whatever, that specifies the minimum number of input channels. There's a default for every class type, but the user can override it if they want. That's what I'm thinking. So the total amount of channels will always be the number the class specifies plus 1, because 1 would be your autopilot switch. Where did I find this stuff? Inside the shared, right? So there's the class. So we want to expand on this. Instead of just having a single identifier to specify what class it is, you want to give it a whole struct. I've seen some stuff in C++ that I know exactly what I want to do. I just don't know how to do it. I'm not good enough for this language yet. Let's see, where's type class used again? It's used in the type configuration. Oh wait, this was... I already started building it, I think? No, wait. I did, but also not. I want to rework this. See, the way I have it right now is the input and output is the same except for the autopilot switch difference. So let's just call this channel count. Shit, but I also haven't built it in a way for that mixer system yet. Where did I put that image? This is ugly. I should redo this image. This doesn't... It looks like a child's drawing. I guess I'm still a child. I like playing. Can draw.io do this? I guess it can. Draw. Come on, stupid fingers. Draw.io. Let's open this here as well. Okay, so if we have, say, our vehicle, can we do this with a dotted outline? Yes, we can. So we'll have multiple inputs like this. Oh shit. And then we'll have outputs similarly. And then the autopilot switch is going to trigger a change in input system. Okay, but hold on. This system doesn't cater for... If it's a vehicle where maybe you want to switch some auxiliary channels, basically. Let's not do it. Also, So you have that mixing system in between that I still want to implement. So I'm going to have to create defaults. We're going to have to create them in a way that's user overridable. So the user could create their own class types for either an output system, an input system, or a mixing system. Put our mixers. And how the mixers are going to work is, it doesn't have to be one-to-one, it could be one-to-many. Fuck, I'm not going to draw lines, screw that. I can just symbolize it with text. God damn it, make me click. Bad devs. Okay, so that's pretty much the fundamentals, but the reason one is solid is because one of each minimum is required. And I'm thinking for this sake, because it's a hobby project, it's not a professional autopilot, I'm thinking the input system assumes you're always going to have an autopilot switch. Unless you are going to use the system only for mixing your radio to a different type of vehicle, then no, we should not make that assumption. So we also cannot make the assumption of having a channel count plus one all the time. This is a tricky one. Fuck. I gave it a lot of thought like a week ago, but I think it all slipped out of my mind again. You want output systems to switch, you want input systems to switch. It needs minimum one input, one output. It does not need autopilot, but it needs a system. So this is the other thing I'm also thinking. Instead of having this just inputs, outputs, and mixing, we have event triggers. Like if, no, but still it has to be bound to an input or output. So you bind an event to an input system. If something like you flick a specific switch, it triggers an external event telling it to switch to a different input or some shit like that. Fuck, but no, then that same switch that triggered should still be enabled so that when it switches back, which means one input system will always have one of its switches bound to a system-wide thing. That does make it particularly tricky. Like your autopilot switch. So what if we then... Fuck. I need to think about this. This is a tricky one. What if the autopilot thing only diverts your If you build a bare bones system that doesn't know how to map the inputs and outputs and everything has to be specified by the user, I guess I'm fine with that, because there's no default. I mean, shit, you can't just assume a default vehicle type everyone uses. Okay. So if I go that route, now I think instead of having an input-output system switch, we have to look at having individual channels switched. And a specific channel can trigger an event that does the switching. Yeah, which means this whole system I thought out last time won't work either. It's a good foundation, but I need better event management, better high-level vehicle event management. Fuck. So what if instead of having entire input-output systems, I have every freaking channel granular and every mixer is granular? No, but then how do you consolidate? Like, let's say you've got a quad rotor where you receive 4 individual channels, but you output each one of them mixes each one of the 4 outputs. I still need, but you see, a mixer, I thought about this last time as well, a mixer should be scalable. Its inputs and outputs should be dynamic. So if you can pause, oh fuck, no, this is very tricky, because this is something I could also do better in C# than in C++, is building dynamic shit like that. I don't know how to do it in C++. Unless you just build everything with the assumption they get the right amount, and no. Unless your mixer is an object, custom built for the vehicle type. You pass in the value, you manually have a handler inside the vehicle manager that gets all the input values, passes them into the mixer, which means the mixer will have a function signature that only accepts 4 inputs, for example, and will only return 6 outputs, as another example. But then mixers won't be scalable. There's a pretty complicated thing that I need to try and figure out. Unless, nah, I was thinking of just sending the number of inputs and outputs through as parameters, but then you still need to know how to mix, so your mixing is going to be kind of hard-coded anyway. So Only thing I can think of is hard coding this shit. If it was C sharp, maybe I could find another way, but I'm too big of a noob with C++. Also, a lot of this foundation is now going to have to change. God damn, I got myself caught in a pickle here. Okay, so again, we're going... Oh shit, what was that? My bad. You're going with the assumption that we don't need an autopilot. It's optional. For in case you want to do RC mixing only. In which case, you're going to have a bunch of input channels you're capturing from. You're going to have a bunch of output channels. I mean, you could just do one-to-one input-output. But effectively, I need a module between the inputs and outputs that tells me how to mix the inputs and outputs. Could have a different amount of inputs versus outputs, and should also be user scalable. The user scalability part, I think, might be a lost cause. So I could ship it with the one basic mixer of mixing 4-channel aircraft signals into a quadcopter signal. And then people could build their own mixers on top of that. With no default. Let's go look at the code a bit. So got our input and output. None of this is coded yet, so the input system doesn't have access to the output system yet to trigger any events on it. But the idea is for it to work that way. Unless the input system triggers an event inside the mixer. And the mixer triggers an event in the output system with a dynamic array of elements. And then based on vehicle type, we assume with a quadrotor we're getting at least 4. That's post-mixing, correct. That could work. Fuck. Wait. Before my brain loses that. Input triggers event in mixer. Mixer updates output with new parameters. Because how it works is the input system, upon input capture, every time your RC receiver square wave, every time it outputs one cycle of a square wave, it's going to trigger this. Well, technically, it's going to trigger it twice. One for rising edge, one for falling edge. And then Oh fuck, the code's not there yet. But basically this will look at which timer it is, which channel. Oh, but again, this shit's all hard-coded. No, I mean dynamic right now. It used to be hard-coded. This dynamic stuff could be a nightmare in C++. For me, at least, being this language still intimidates the shit out of me. I'm fine with keeping it dynamic, even if we hardcode indexes for an early test. Okay, so we keep our input channels dynamic. When the input capture happens, we're gonna access the individual input channels based on their index, but we're gonna need our old code to do that. Wait, actually, didn't I have a second repo open? I did. Where's my... I think it was this one. This one was the other branch, the old code. How do you open this again? Huh? Oh, this is Linux. I forgot. My bad. Oh, and also not Explorer. It's called... What's it called here? Discover? No. What's the browser called? Dolphin? Ah. How do I know? Wait, don't I have it open? Actually, I'm an idiot. Don't I have it open here? No, I don't. I've got it open in Eclipse. Because I can't import the same one with the same name twice. This is where I had it. And now? Oh, there. Other window. This was the one. Okay, so this is our old input capture function. So we need all this code pretty much carried across. Now I'm just going to copy this because I'm lazy as hell. And then I'll fix it here. Ooh, wait. I forgot this stupid wannabe version of Eclipse that they use here doesn't paste correctly unless you copy it a specific way. There we go. Okay, so we're going to assume channel 1 is always going to be the first entry in that index. I can't remember the type that I used. There. I'm an idiot. Oh, what am I doing? So technically that's still a pointer. So now if we go... wait, we can use this as a pointer. So then you go arrow... timer. Where's timer? There. You could actually simplify this a lot. Come on. Wait, how do we get that? Oh, we have the index there. So... See, 0 index is a thing, so I can't just make this 0. It's unsigned unless I just make it signed int. Make it something like a -1. Yeah, that would work. Okay, so if it's channel 1, then the index is going to be 0. And then we're going to move all this code. Actually, not that variant, this variant. Copy it properly, otherwise this thing screws me around. And we're going to move that out of the case statement. Trying to think if there's cases where this won't get a hit, but no, in theory, this will only ever get a hit with an input event, so it should be good. Okay, so what we're going to do then is move this one over like so. Let's comment all this out. No. Comment that out. Zero, 1, 2, and 3. Okay, so we just set the channel index, and then we're gonna go yada 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 channel index. So you get the correct channel, and then we go channel 1. Oops. Timer. Oh, come on. Autocomplete not working when you want it to. Timer channel. And then here it's timer.gpio port, and then timer or channel.gpio pin. Does that function even? Oh, I haven't moved it over yet. I'll have to bring that function in. Then this is where we trigger, instead of triggering our output system, here we're going to trigger our mixer system. So all this code for now, I'll keep that first function in. Oops. To that. And then this function. Might as well just make its definition ourselves by doing this. Actually, we need to fix that as, oops. We still have the high and low tick on this, don't we? Yes, we do. But it was high tick that I just erased, wasn't it? Yes. Okay. So we still have those values on there. Then we need this definition inside the header file. Like so. Standard clamp not working because we need, what we need is not in there. It is inside the header file. Isn't it open here? Is this it? No. What is this? RPV. Come on. RC. Wait, why am I not seeing it? Is this the one? No, it's supposed to be called input capture. Oh, I'm looking at the wrong one. I'm an idiot. Huh? Wait. Wait. That's the one. What did I even want here now? I forgot because I went to such a mission. What did I want from this? Oh yes, the headers 4. I think it's just this one. Oops. Algorithm. Let's put this in the header as well. Wait, which one is it? I'm busy. This one. There we go. Clamp is working now. But again, I was rethinking the float because floats are heavy on memory for these microcontrollers. I shouldn't be using float. I should be doing better math. But anyway, so there we get our duty cycle. Now we have to send it into the mixer. But that'll come later. This code, in theory, should compile, I think. No, because I haven't defined those yet. Also, I need to completely rework. I forgot about this. I'm doing this wrong as well. I need to rework the system, the way I calculate this. But I'll do that later. For now, I'm going to stick to this. But yeah, I think this code should compile. No, it does not. Why? What did I break? How did I do that? Where else? It doesn't like that. Wait, why? Cannot convert. No, but it is a pointer. So I definitely should not be doing that. No, because that's address of, meaning that I'm getting the actual value. I should not be doing that. No, wait. No, address of gives you the address value of the pointer. The star gives you the value. But that is a pointer, and this is a pointer array, so giving it an index... No, man, that can't be right. Should I do AND again? Oh, fuck. I changed this. Damn, I broke a lot of stuff. Idiot. Same thing, different area. Oh yes, okay, this is a lack of declaration. I need these. This one? Yes. No, clean, bolt. Okay, now it bolts. Okay, cool. I might as well get rid of all this commented code because I have it somewhere else. So, makes it look a bit better. Stream break? Oh, that's a shit ton of drop frames. How did that happen? When did that happen? It must have been recent because my Twitch window went a bit bonkers. Sort of ban these bots. I guess my stream broke a bit. But yeah, okay, so now I actually want to redo this while I'm at it. So instead of what I'm doing here is I'm counting the square wave pulses to get a percentage-based duty cycle. I should not be doing that because I learned recently that an RC square wave is sent in 200 minutes. No, wait, fuck out. What was it? 1.5 milliseconds to... Okay, so it's from 1 to... So it'll always have a square wave that's either 1 millisecond to 2 milliseconds long. 1 representing the furthest left endpoint, 2 representing the furthest right endpoint, which means that for most cases, the default value would be 1.5 because your stick would be centered. So instead of counting a percentage-based square wave, I should be counting the time. So even though this, in theory, should be accurate, it's not the way you do it with RC stuff. So I need to redo this. Thing is, though, we're using ticks here, and this clock is being slowed down. So I have to get its prescaler and divider and whatever, calculate its tick to time ratio, and then I can determine how many milliseconds this thing's been counting for, or microseconds. So let's look at this. So we're looking at, what was this? The output. Wait, what was I looking at now? No, I got confused. Input. So the input system, okay, this is still capturing the square wave, yes. So, go back to where we were, go there. It would be timer 2 and timer 5, which are input capture. And this is our prescaler. What's our clock speed? 72 megahertz? Yeah, 72. So 72 million divided by, what was it? 23. So we divide by 24. How does this work again? Pretty sure it's 24. That's 3 million. That's 3 megahertz input capture speed. 24, yes. I know the receiver, based on the oscilloscope, tells me it reads at 62.5 hertz. So 3 megahertz is way faster. Now let's think if you take that divided by, say, 6 channels. 3 megahertz, so that gives us 500 kilohertz. Theoretical capture speed per channel in a 6-channel scenario. I think that's good enough resolution. That means it's 500 capture samples between that 1 and 2 milliseconds. 500 on each side, so it's 1,000 total capture samples. I actually want higher resolution. Maybe you should go higher. Maybe I should bring down that prescaler. Okay, so if I have 500 on each side, 1,000 in total, I want 8,000. Yeah, I could just use this. Wait. I'm an idiot. We have 3 megahertz. Can't even handle that speed. It should be able to. Okay, so we have 3 megahertz. We want to multiply. I'm scared it might be too much for this clock to handle. Do we have any other dividers? No, we don't. Or it's going to overload the chip to such an extent that I can't do much other work if I'm capturing too quick. That's why 3 megahertz, I calculated, would be pretty good. Fuck it, let's do it. Oh no, that is my clock speed, which means I remove the prescaler. 72 megahertz. No, wait. Oh shit, wait. Yeah, then it's going to work really hard. Let's at least make it 6 megahertz, which means, oops. Well, it should just be doubling that, but I'm not sure if the prescaler works. Wait, let's see. Yeah, it does work that way, so 11. So if you're capturing at 6, but see, the thing is that The input events are still only going to trigger at 62 hertz, but with multiple channels, it's a bit quicker. But it doesn't matter because where we pull the tick value, let's just save this in general. Oh, fuck. I had a change file again somewhere that I never saved this. What? No, don't change perspective. I'm still debugging. Yes, I am. I never hit that error handler, did I? No. Chip's been running the whole time without hitting the error handler. I forgot about that completely. But yeah, it's weird. Maybe it wasn't USB related then, the last time it happened. I have a USB connector. I actually forgot about that. Okay. Where was I now? Oh yeah, the input system. I was still busy with those functions. Closed it. Okay, so if you're running at 6 megahertz, you could just take the time and multiply the difference in ticks and multiply it by 6. But hold on, that is... we could just... There's a way to get the system clock. I can't remember how I did this. Pretty sure it was like a get sys clock or something. Get tick is the current tick. I don't know if that's it. How did I get it last time? Let's just Google it. That could be the one. This one looks more familiar. I don't know. Let's try them all. One of them gets us the clock frequency. Oops. This one does seem to work, actually. Oops. What is this? A STM32 or bigger? I think I just copied right after I erased all that. So, somewhere in the main. Collapse everything. Here. Breakpoint's disabled again. There's some button I press that accidentally does this. Skip Control Alt B. Where do I hit Control Alt B? Huh. Let's debug this. See what that value is. It should be 72 million, I think. Oh, need to resume first. There we go. 72 million. So that other one I saw, H clock, where did that guy do it? This. I'm wondering if you can get a separate clock frequency. Okay, but hold on. The prescaler, I don't think that'll work. We can just take this and redivide it by the prescaler. So let's do that. Oops. What was it? The input system I was busy with. There. Let's close everything else. Okay, so we need our clock frequency. Then we need the current channel. Ooh, can I even get this? The current timer prescaler. Is it instance? I think it's instance. PSC, I think that might actually be it. PSC is the prescaler value. We can actually go check it in the generated code, which I think is also in main. Let's collapse everything again. Look at the... Is it a timer in it? I think it would be. 23. We're looking for... Oh, there. I changed it. So it's init the prescaler. I see. Aha. Can remove the outer brackets. I was over bracketing there. So main clock frequency divided by the prescaler will give us the current clock frequency, which we will then use based on the number of ticks that have elapsed, determine the current amount of time that has elapsed. Something like that. But I don't know. Well, so you know that it's going to happen X amount of times per second. What is our clock frequency? 6 million. So that's 6,000 milliseconds. No? Yeah, 6,000 milliseconds. So you count. We already got all the ticks we need here. But this part here, this is what's going to have to change. And then this clamping math at the bottom. But this, we need pulse ticks. No, wait. So I need to count the difference in ticks and still form a percentage-based value, I think. No, I don't want to work in percent. I don't want to work with floats. Floats are heavy. So if we return the number of microseconds, because I think milliseconds is not granular enough. I need microseconds. But still, microseconds. No, even microseconds, 1500. No, that's actually pretty granular. And the fact that we bumped it up to 6 megahertz should give us a better frequency, a better resolution. So you return microseconds. Also, we need to rename this. So this is basically going to give us the number of microseconds high. Is the dot header. So yeah, this needs to calculate microseconds. Where do I use the low tick? Here. I need to stop looking at this code. It's confusing me. I need to rethink all of this. Oops. Wrong button. Hey Lucy, it plays. I'm not sure if you're still there. What's the timestamp? It's 10:03. I miss you by like 3 minutes. But if you're still there, I'm pretty much coding a project that you connect a radio control receiver to. It then mixes the output of that and then outputs it to your radio control equipment. Basically, all the radios can't fly quadcopters. They can only fly airplanes and helicopters. And this project will then make those old radios work with quadcopters. That's the idea. But yeah, I'm not sure if you're still there. If you are, that's the lowdown. I need to think now. This one's got my brain stumped a little. We need to figure out how many microseconds elapse in a single tick and multiply the difference in ticks by that to get the time that's elapsed. So if it's 6 mega, hold on a second. Wait, this thing. So our sampling rate might happen at 6 megahertz, but the speed we're working with is much slower because the receiver is about 63 megahertz, 62 megahertz. So from the moment we read a high pulse, we take the previous high pulse, so we read tick value. That is our high pulse. And calculate using the previous high pulse the same way we did before. I think we can leave that the same. We actually don't need the new tick. We only need the previous ticks. We need to count the difference between the previous high and previous low. Oops. And then afterwards, we're going to do this. Input channel dot high tick equals that value. Wait, did we just what size can we make this? A 16 is adequate because this will never be such a big number. There. Okay, so what we then need to do is on the mixer system, either we can send through a percentage value, but for the most part here, I only need the number of ticks in microseconds. So you could build the mixer system to accept multiple types of inputs. But I'm thinking for now, we stick to this. As much as I want scalability, it's just overcomplicating shit. So I'll do that later. Doesn't need a number because there's only one. I still don't understand this. I had to give it an address of, even though it's already a pointer. So I assume if you access a pointer using an index, it then gives you the instance instead of the address again for that. Oh, but hold on. If it's a memory space, it only has one address. Doesn't have an address for every item or every index item in the index, if I remember correctly. That makes sense. Okay, so this is the basics. Now we need to build a mixer system. Oh, I actually had that code here. I just missed it. This isn't going to compile because of this not returning anything. So how are we going to do this? We get to running. Wait. Okay, we still need to take our clock speed into consideration because the ticks are obviously relative to its speed. So we're going to take low tick minus high tick. Oh, wait. I'm an idiot. Wait, which is a larger value? Low tick is going to be larger. Yes, so it is right. That is right. So we got our clock frequency. We got our tick difference now. How do we do this though? So microsecond is 1,000 milliseconds, I assume. Not 100. That is 1,000, yes. So 6 million, i.e. 6 megahertz, is 6 ticks every microsecond. Am I right? Yeah. So 6 ticks every microsecond. So every 1,500 microseconds. Well, up to 2,000 microseconds. Let's just Google that again. I'm not sure about that. 1 millisecond to 2 millisecond, yes. Okay, so 6 ticks per microsecond There's a tick count. So tick difference. Wait. 6 ticks per microsecond. So divided by 6 equals the microsecond number. Okay, so wait, we get the difference. We divide it by 6. That gives us the on period microseconds, which is correct. That is correct. So, in theory, this should work. Why are these all 32s? Well, they should be because of this. Did I even need clock frequency? Why did I not use clock frequency? Because I wanted to calculate what that value is. The smart way would be to calculate it. I just hard-coded it. Fuck it, YOLO. Oh wait, I should multiply. Multiply by 6. No. 6 ticks per microsecond. Yes. Yes, that's right. I wonder if this will work if I test it. Probably not. No, it could. Let's go check our input capture event. Oh, it wouldn't be wired here. It would be wired here. There. Input capture callback is wired to our RPV manager's input capture. And our RPV manager's input capture is wired to the input system's input capture. And when an input event gets triggered, it gets the channels, does the calculation, and then updates the values. Now we want to see that value once it hits. I think I do have another breakpoint somewhere. I want to remove the error handler one. It can stay in case we do run into an error. I want to see. Okay. Now I need to go strip my receiver out of my plane. Give me a sec. Okay, so receiver is hooked up. If I debug this code now, I can't put conditional breakpoints, so I can't do like if channel is 3, stop. Trying to think of a smart way of doing this instead of going through every one. What's the first channel that always gets captured? Let's just run it and see. Debug. I did not save this. What resource is this? The current file. What did I change there? What did I change? I fucked something up. How do you redo? There. Yeah, I pasted some weird shit there. Now it should compile. Why would I do that? I do shit like this sometimes. It's the worst if it's like you code the one day, the next day you come back to work and you're like, why is my code broken? And you find you've pasted some weird shit. I've done that when I'm very tired. But yeah, let's not talk about that. Okay, so if I run this code, resume. Where was I? Input capture. Where's this? Oh, there. CPP. So we should see this getting triggered. It is not. Why? Because I don't start the input capture. That's why. That is why. Let's turn off the radio for now, just to save energy. How do we do this though? Going to assume 4 channels for now. Actually, I think I had code for it that I removed. No, that was in the output system to set the pulse width modulation to 0. I never had code for input starting. So let's do that then. Fuck, now I need to remember, it's Altum IC start. I think, wait. Start DMA. This one. Channel data length. Okay, so the data and the length, I needed an array for that, which is not a problem. Let's first do the other one. So it's going to be channel 0. We need the AND symbol. Dot timer. Do we need the AND symbol? I guess we do. It doesn't give us an arrow either way. Come on. Clumsy fingers. Okay, then the data and the length would be that array. Now you can just create it here. What was it? 32, I think. Doesn't like this. Why? Why? What happened to the music? It's a song with a weird ending. There. Okay, so it does not like this. Why? So you give it a timer, you give the timer channel. It can't be this though. Because that one is the one I know for a fact you need the address symbol. But there it needs... I guess it's only if you reference it like this. Maybe. I don't know. Weird. Like so, that should work in theory. It hit it, so that means an event occurred. Okay, so now we turn on the radio. Where do we want to stop? Over here. Boom. Which channel are we capturing? Channel 0. Fuck, which one's channel 0 again? Channel 1 is roll. That's not right. It should be giving me 1500. That sure is, unless the debugger is messing with something again. Am I doing something wrong here? Oh no, the value looks right. It's just... Did I mess up the math? Is it IOC? I forgot about timer 5 being different. I never... No, wait. I changed timer 2 to 11, right? Yes, but I never changed timer 5. I should have changed this one as well. I forgot. That could be... Because roll would be captured by timer 5, so that could be why it gave me a wrong value. No. Let's try again, just out of curiosity. CPP file. Go away, tooltip. City tooltip. That still does not look anywhere near correct. Which channel are we capturing here? Channel 0. Why is it always channel 0? Channel 3. Okay, so it's not always. But the debugger will give you inconsistent results. Why is it giving me such large values? Taking our main clock divided by 12, which gives us our prescaler. That's 6 megahertz. Six megahertz, yes. Six megahertz, 6 million times a second, which means 6,000 milliseconds, i.e. Well, yes. 6,000 times per millisecond, 6 times per microsecond. No. This only triggers every time there's a high tick, which assumes a high tick would have occurred before. It takes the low tick, less high tick, which gives us a difference in ticks, takes that divided by 6. That should give us the amount of microseconds. but it's not. What am I doing wrong? Let's record the tick very quick. Wait, I actually do it here. 105, 153. Oops. I'm definitely doing this right. As far as I'm concerned, I'm definitely doing this right. Mathematically. Unless I'm doing something else wrong here. You set the tick state, you set the pin value. Unless I'm referencing that wrong. No, this needs a timer as an input. That's not a pointer. The port is a pointer, but could this be where I'm going wrong? No, because you're triggering. Are we? Yeah, we're definitely triggering the low as well. Otherwise, it wouldn't be able to read it correctly. You could be going wrong. This is baffling me. I don't know what I'm doing wrong. In my head, theoretically, everything makes sense. Everything is correct. Fuck. Let's hook up the oscilloscope quick. For a second, this thing confused the crap out of me because the values I saw is different than before. But then I remember I set it on my plane to have more, what do you call it, endpoint traveling. So yeah, but everything reads right on the oscilloscope. So I'm getting one. Wait a second. Wait. Yeah, ms. So I would assume that's milliseconds because it's 1.5 and 2, or 1.5, 2. Doesn't make sense how I'm getting it wrong. How would we know? We could manually calculate how many ticks we're expecting. So if we go... Fuck, how do I do this now? 1500 times 6. 9,000. That should be a more or less a tick difference. 15. This time it gave me a correct value. That looks correct. Why the fuck only now? What the hell changed, man? Schrodinger's cat. Once I observe it on the fucking oscilloscope, the values change. What? Okay, that's not right. Definitely. Although I do remember in other cases in the past as well where every time I hooked up the debugger, shit behaved different. So the best way to do this was to capture all 4 channel values and then observe them at once in the debugger. And that usually works. So what I'm going to have to do is on this input channel, I'm going to have to store a thing. Oh, come on. This is going to be call it duty microseconds. Because technically it's still its duty cycle, the period during which it works. So now if you clear this list, where is this, the watch list? Is this the watch list? I think so. Yeah. So we add all of them. Wait, we can't add all of them. We're going to have to add that thing to the watch list. Let's debug first. Oh, we are. So you can just go, add watch expression, and then we say it needs to be an array. Where do you do that again? Edit? Oh, wait, there at the bottom. I saw it there. Display as array with a length of 4. Okay, so right now we won't see shit at the moment. We put a breakpoint there. We still don't see shit. Why? But why? Oh, because I used the wrong one. Needs to be this local one. Oops. Come on. Display as array with a length of 4. And then we remove this one. What am I looking for? The value I just set. Wait, what did I call it? Duty. Why am I not seeing it here? Duty microseconds. Am I blind? It's not in this list. The fuck? Why? How is it not in the list? My own variable. Well, my other own variables are there. Why is this one not there? A weird ass thing. Why is it doing that? Maybe I need to clean. Oh, I was stuck in the old. Maybe I didn't recompile before debugging. I think that might actually be the case. Let it run for a bit. Wait, now it's trying it wrong again. There. Duty 15, 12, that's throttle, 15. So now it works correctly. So it's an observation problem. It's not actually a code problem. My code was correct. The debugger fucks with my values when I observe it. So yeah, now it's working correctly. So in other words, if we bring the throttle all the way down, the throttle won't be at 1 because it has some endpoint adjustment that prevents it from going there. But let's just run it for a bit and then stop it again. So channel 3 would be this one, 111. And if you put it all the way to the top, let it run for a bit, then it should be closer to 2. There we go, 19. But now with all the other channels, I have full endpoints, which means it should go from 1 to 2 all the way. Oh, come on. Breakpoint. Okay, so we'll pull rudder, which is channel 4, all the way to the left. Put the breakpoint and observe it. 999, so pretty much exactly 1. So that is accurate, quite accurate. Resume it again, pull it all the way to the right, put the breakpoint back, 2028. So it's slightly different. Could be my calculations that are slightly flawed though. Higher resolution than 6 would be nice. But also I want to actually calculate this dynamically so that I can just change the prescaler and this updates accordingly. This will give me 6 million. So if I divide it by a million, it gives me that value. I think that's one way to do the math. Take this, divide it by a million, and then use that value there. Let's test it. Turn off the radio to save some power. Take the clock frequency, which is that, divided by that, divided by that. Shouldn't actually call it clock frequency, but whatever. Let's debug it, turn the radio back on, see what it does. Let it run for a bit, and then put the breakpoint, read the values now. I have to convert it to an array first. Still seems correct by the looks of it. Throttle should be low. Oh no, I left it in the center, never mind. Okay, so that still works, but now if we go and change the frequency. Make it faster, faster, faster. For both timers. All my other files are saved. Yes, save this. Regen the code. That should run a lot quicker. But the values we read would still be the same because it's dynamic. Well, that's the idea. What? Oh. Get rid of the breakpoint. Let it run for a bit. Stop it. Change this back to an array. Where's my numpad there? 4. The values didn't change much. I was hoping it will improve the accuracy. Let's take throttle down all the way. Well, it doesn't have an endpoint. Let's go rudder. $909 still gives me $909. $2028. So the values didn't actually change even though I increased my resolution. So it's not a timing problem or not a mathematics like rounding problem. It's something else. Which means I don't like those values. It's not exactly 2 milliseconds. It's 2.028 milliseconds. I don't know if that's going to fuck around the system. I mean, it's 1%. On the higher end, it's a 1% difference. Let's see if the aileron and elevator would do the same. Remove that breakpoint. Resume. Push the aileron to the side. Put the breakpoint back. Let's check aileron, which is the first channel. 2037, so it's even higher than the other channel, the rudder. Oh, come on. Okay, now let's test the other endpoint. 1008. So this one is offset slightly. Now aileron and elevator is usually very, very similar. So I'm expecting to see the same numbers with the elevator. Run for a bit and stop. Which is channel 2. Actually different. Interesting. $2030. But I mean, shit, it's still very close. Okay, hold on now. Center points was the other one I wanted to see. Let's actually put the breakpoint back. Aileron center is, where is the time? 1523. 1514. 148. Oh, that's throttle, never mind. 1515. So they're not perfect either. But it's very fucking close. The clock frequency you can also hardcode instead of calling a function every time. Even though this just returns a hard-coded value, isn't it? Or not a hard-coded, but just returns a value. No, it actually computes or some shit. Let's rather store it instead of calculating it each time. Like so. And then we use that variable over there. Okay. Turn off the radio just to save power. But yeah, this does seem to do what I wanted to do for now on input capture. And then I guess we'll build the mixers and the output system next streams. I'm going to call it a night for now. It's already almost bedtime. Or supposed to be bedtime. It's okay, Stream Hub World. Sorry, I missed your message. Didn't see you there on Kick. I'm normally focused mostly on Twitch. And Lucy Plays. Oh, thanks for the follow. I didn't even see that earlier. What? No, why did I do that? I accidentally clicked something out, deleted a message. My bad. I can be an idiot sometimes. But yeah, I'm going to call it a night if there's anybody still there. Thanks for popping in. I'll catch you guys again on Wednesday. Last week of streaming, so yeah. Friday's the last stream of this year. Anyway, have a good night. Cheers, cheers.